Hi, everyone. Thank you for coming. I'm very excited to see a good group of industry presenting today. I'm very excited for this event. We have been in conversation with quite a few of you, but we're excited to broaden the conversation and have this amazing group of people share their expertise with us, but also hear your input. So very quickly on the agenda for today, I'm going to start with a brief context of where the Vancouver Building Bylaw, embodied carbon in the Vancouver Building Bylaw has been coming from, and a little bit of a background. Then I'm going to quickly pass it over to a great group of presenters. I'm not going to name them. They're going to present themselves. It's a jam-packed session, so I'm hoping that I can save the time and let them introduce themselves. Then I'm going to move to share our proposed approach for the embodied carbon requirements in the Vancouver Building Bylaw, which is the Vancouver Building Code for the 2025 update. We're going to have a brief Q&A part to answer anything that is unclear from what I'm presenting, and then we will go to the breakout discussions and then come back and regroup and share what we heard in the groups with the broader community. So on the context, I'm going to start by saying that we are very excited, and I'm hoping, and I think a lot of you have already noticed that the embodied carbon policies are growing pretty fast for Vancouver. We have embodied carbon as one of our targets in climate emergency action plan, but the provincial government and the federal government are all also moving toward developing targets and resources. So these are just a couple of examples. So federal government, for example, as part of their greening government strategy, have the target of reducing the major construction projects of the federal projects by 30% by 2025. So for us, City of Vancouver, as part of our climate emergency action plan, we identified few major actions. We call them big moves, and big move 5 basically is addressing embodied carbon, which sets the target to reduce embodied carbon by 40% by 2030 for all the new buildings in Vancouver. So this was the climate emergency action plan was released in 2020. And as part of it, we also had an embodied carbon strategy alongside with it, which we identified the way we are going to achieve that target. And we identified 4 key action areas. One of them was changing the rules, and that relates to the zoning, the codes, and the requirements that the city has, both for city-owned projects and also for all the other buildings that are in Vancouver. The first step we took was back in 2022. We approved the first step, which came into effect last October 2023, which we started requiring embodied carbon reporting and set the first limit, which was less than double of a baseline following the embodied carbon guidelines. And then at the same time, we also brought to council our recommended approach for the 2025 step, which was what we brought to council, which was approved in principle, but the details was to be brought to council later, basically this year, which that's exactly what we are sharing with you. What we initially proposed was 20% reduction for buildings that are up to 6-story, basically lower rise buildings that can be built with wood, and then 10% for all the other buildings. We also had this requirement of responsible material sourcing criteria, which was a set of criteria that we set that we thought that are important to material sourcing and embodied carbon, but not very well addressed in the current systems that we have for embodied carbon assessment. And so we had that as a proposed approach, that each building will meet one of those criteria or double the reduction requirements. So that would bring the wood building requirements to 40% and all the other buildings to 20%. But another important step that we took when we started our requirements for the 2023 was the release of our guidelines and reporting template. So these were key in that we made sure that we have a standardized compliance pathway set. We have standardized embodied carbon modeling through our embodied carbon guidelines, which are available on our website. I just have a screenshot to the right, you can see. So how to model, how to set the baseline, how to document and submit for approval. And all of these were set for the building permit stage, basically. And then we had a standardized reporting template. And we are very excited to see that the guidelines have been received very well throughout Canada. Federal government is looking at it. CAGBC is looking at it. So it's good that it kind of created this ecosystem of making sure we are all aligning, and if there's variations in the approach, is very clear and minimized. This is all I have at this point. I'm going to pass it to our presenters to share their experience on how they have been assessing and reducing embodied carbon, how the current version, the 2023 requirements of Vancouver Building Bylaw may have impacted their projects, and what they see coming as we move toward the next steps. After the presentations, I will come back and share with you our proposed approach for the BBBL 2025. What I would say that I was quite excited to hear these presentations or having the conversation with them was to understand how these may apply to code. So I'll ask you all to have that in mind as you're listening to the presentations, and then again I'll come back with the proposed approaches, and then we can discuss those further. With that, I'm going to pass it to, let me actually first stop sharing my slide, our first presenter is Chad. So I would ask Chad to share his screen, and if you would like to start introducing yourself and start with your presentation.
Okay, can everyone see my screen? Doesn't
Yep.
look, hang on, I think I got the wrong screen. Share screen. It's this one. Okay. Does that work? Okay. Yeah, I'm Chad Cranswick, BC Building Science. Just want to kind of share my experience as a building science consultant. As you can see on the screen, this wall assembly here was a passive house we worked on many years ago, and it was kind of the passive house idea started to push for what you'll notice. There's a lot of materials in it, a lot of wood and a lot of insulation, and that was sort of to achieve the ultimate goal of super energy efficiency. So this piece, embodied carbon, what was, in my opinion, what was kind of missing from that, because those ultra energy efficiency single goal ideas tended to ignore the embodied, the sort of the responsible use of materials. So that's kind of what this is about. So that's why I support what the City of Vancouver is trying to do here, or is actually doing. So the goal is kind of to focus on not just operations, not just operational carbon, but on materials as well. And I think the two of them sort of balance, and overall, it's about responsible use of resources, whether it's energy or materials or anything. So I want to share a few case studies we did, which are kind of interesting results, and only got a few minutes, so I want to be quick and rush through. So you guys have all seen this type of chart. Well, hopefully most of you. This is basically operational carbon is what we've been dealing with over the life cycle of a building. These are sort of years or represent time along the bottom. And operational carbon is what we've been focusing on. That's what the step code deals with, is trying to reduce the amount of carbon that is being used. The other piece is this embodied carbon, and that's what's being addressed by this new, not so new, but section 10.4 and the City of Vancouver's green building policy for rezoning, which has been around quite a long time. But that's what it's trying to address. Does that make sense? This is kind of like, reminds me of these financial plans, like a mortgage or something, where you have a high buy-in at the beginning, and then smaller payments throughout. So we just want to show two examples. One's a townhome, and this is sort of a voluntary one we did internally. Townhomes, this type of building actually wouldn't apply. As I understand, 1 to 3 story, it's slab on grade. There's not a huge component of concrete, but it was an interesting one. This is a street side Qualico development. We worked with E3 on it, and we basically did a bunch of presentations for Township of Langley. I don't know if any of you were on them, but Streetside had agreed to turn a few blocks of the townhome development into step 5 net zero. And don't worry about all the details of this, but basically there's a step 2 block and a step 5. There's a few step 5s and a whole bunch of step 2s because that was the requirement. So, but the challenge was, how do we basically scale up the same architectural design? Whereas a lot of the step 5s would be designed from the ground up, and they would tend to form a certain geometry. We didn't have that luxury. So all we did was like easy ones like triple glazed windows and add exterior insulation, but essentially they're the same. They're essentially the same, just with those few scale ups to hit step 5. So we plotted them out together, the embodied carbon. And you can see that the step 2 is the yellow, the step 5 is the orange. So there's less of an investment in materials in the step 2, because there's less stuff basically. But then over the life of the building, you're using less carbon. There's a less carbon impact. So we thought if we add them together, we'll get the total. Like step 2 obviously has total operational is going to be worse, and step 5 is going to be better. That was the investment we made with this embodied investment. That makes sense. So embodied, of course, is higher on step 5. There's more stuff, but there's the gain. Thing is, when you put them together, you get sort of an interesting result here where there's actually a less global warming potential, less carbon essentially on the step 2 versus the step 5. Now, there's an hour's worth of disclaimers about this, so we've thought about them all. This is how you calculate it, and this is the result you'd get if you follow the rules. But things like, the embodied carbon calculation doesn't necessarily have a chance to be fully electrified, like construction, for example. So there's a lot of room there. So as that gets a bit of pressure, you'll start to see these balance out a little bit better. Plus the error probably accounts just for that much. But the overall point is they're not that far off. So it makes you think, like, maybe, was it worth the investment? And I think we've got to look at buildings a little bit more with it all in mind, not just drive towards step 5 so fast. Drive towards step 5, but do it with responsible use of materials. So there's a balance in there somewhere. So let's look at a quick concrete one. I won't go through it too much, but we had the opportunity to basically model them two steps. So step 3, 4 for tower. This is all the details. Oops. Step 3, step 4. Better air tightness, better walls, triple glazing. The details don't matter too much, but the solution, step 3 versus step 4. Same thing. We actually did 2 different mechanical systems just for comparison. So electric and gas. So if it's all electric, you can see the step 3 is a bit worse than the step 4. When you use gas, that's where it gets brutal for carbon. The step 3 really high, and but they're so high compared to electric. which is a key point here. Embodied, you can tell it makes sense. Step 3 is a little less material than step 4. That makes sense. So let's add them up. With electric, so that's this electric one on the left, the embodied together, we get the same result as the townhome. Essentially, they're the same, but the lower step is slightly better, so, or slightly less carbon impact, which is aligned with the townhome and other examples that we've done. So it's interesting, when it's electric, you're actually lower steps have less impact. Very close though, and again, there's disclaimers throughout, but they're kind of comparable, but it's super clear when you get into gas. So when you take the gas and you add it to the embodied, you end up with a huge incentive to go to higher steps. So the underlying message there is if it's electric, it's less important than if it's gas. But there's so much drive towards gas that we can actually start to think a little bit more about the materials themselves and driving that embodied down, because we've driven it down so much with the electrification of things. That's all I wanted to say, and hopefully that was about 5 minutes. But again, overall, it's about, to me, sort of pushing back on this ultimate idea of super energy efficiency, which is great, but think of at what expense? At the expense of too many materials in some sense. So that's it. That's all I wanted to say for today.
Thank you, Chad. That was great context. Our next presenter is Iain and Ayme. So I'm just going to hand it to them.
Thanks, Zahra.
Thanks, Zahra. Iain MacFayden and Ayme Sharma will be walking through experience that we've gained through some projects at ZGF Architects. Next slide, please. So we're looking to put this in a little bit of context in terms of scale of impact and when and how decisions being made can influence the embodied carbon of projects. So we're going to start high level, and then we're going to walk through some example case studies. Next slide. The idea of kind of building nothing, reuse and repurposing. You can kind of argue now that the idea of building nothing is not real, in the sense that we need additional buildings for housing. We need additional infrastructure to support the increasing in population. But the idea about reusing and or repurposing buildings is being carried out in different marketplaces. So if we look at Calgary, they're repurposing office towers at the moment to residential, but that's under very, very specific market conditions, not necessarily translatable to Vancouver or Metro Vancouver. And in terms of reusing and or repurposing within Metro Van, we've got to take into consideration seismic. So we're that balancing act around additional material associated with seismic upgrades required for buildings that are being reused and or repurposed. Next slide, though. One of the biggest impacts that we can have is really on efficient design. And this is, leading off the last presentation in terms of being efficient with material use. Some of the key aspects that we've been finding is the reduction in volume of materials. One of those is being able to focus in and look at reduction in parquet size and structure. Parquets typically have the largest embodied carbon impact associated with a building. If we're able to reduce the parquet, then it has a significant impact on embodied carbon. We've been doing that through utilizing TDM measures, which Ayme will pick up an example later. But that idea of efficient design also translates through the building as well. So where we've been looking to optimize unit plan layouts, looking to stack the 2 beds, stack the 3 beds together, and reduce the use of transfer slabs. And in terms of transfer slabs, if we're able to kind of take out the step backs that we're quite often asked to put into our projects, then it reduces those transfer slabs and the volume of concrete. But when we're looking just at those transfer slabs, that's a cascading effect. So we're seeing that when we're putting in transfer slabs for inefficient unit plan layout or step backs, then we're increasing other materiality through the project as well. So that efficient design has a significant impact in terms of material use. Next slide. Last but definitely not least is the optimizing material selection. This really, in essence, boils down to the selection of materials, selection of low embodied materials such as low embodied insulation products and or optimizing concrete mix designs. We're going to walk through, next slide, a couple of case studies now, and Amy's going to take the mic.
Thanks, Iain. Yes, we just wanted to highlight two projects that we've been reporting on at ZGF that were sort of demonstrating how projects were able to meet the 2023 VBBL embodied carbon requirements. And one thing we want to highlight is that was done at, what we were highlighting is initiatives that are no projected additional costs to the project. So the first example we wanted to highlight, one strategy was, as Iain was saying, the volume reduction, and this was to do with the parkade. So this project is the Vaha Seymour project, which is about a 9-story MER building. So you can see in the baseline, we had 2 levels of parkade. So we were able to move to 1 level of parkade, and that simple move in itself, well, not simple, but that move in itself had a GWP relative to baseline reduction of 9%, which that almost meets the BBBL requirements for 2023. And that volume reduction is actually the most significant change that could be made on this project. And then the second move to for volume reduction was what, as Iain was outlining, that was about optimizing the structure, which involved reducing the slab thicknesses, aligning columns, and avoiding the transfer stabs, and that had an additional reduction of 3%. And then we moved into optimizing material selection. So the GWP from insulation was reduced in this case study by selecting just the CSA approved Canadian sourced materials that already have a low GWP. So we found that the GWP reductions relative to the baseline products could be as much as 80%. So just this slide is just demonstrating that the GWP savings from these different strategies that we were highlighting here. The other strategy that we incorporated into this case study was the optimizing the concrete selection, which Iain is going to talk about in more detail. But overall, when we did the whole building LCA, the results that are showing that the project's on track to achieve an overall savings of 22% reduction relative to the baseline, so far exceeding the City of Vancouver's 2023 VBBL embodied carbon requirements. And all of these options were done at low cost. And the other thing mentioned is this case study is available on the City of Vancouver's website.
Yep, thanks, Amy. Just to reiterate that the savings for Seymour were at no cost, so that the driver that we had on the project was to minimize any of the cost impacts associated with lower embodied solutions. So it really did make us think as a team. This is a good bit of a break in terms of case study. So one of the bits of pushback we typically get is concrete mix designs. It can't be done, it's going to cost too much, it's going to have an impact on schedule. And so what we've been doing is pulling out those components and placing them into performance matrix. So this is a project that's from Surrey, so it wasn't meeting any City of Vancouver requirements, but it's the same thinking methodology that we use on all of our projects now. Is the idea of pulling out the constraints that are coming through from contractors and or structural engineers and understanding what they are from a performance side of things. And specifically on this project, contractor and structural engineer said that low embodied concrete was going to have a negative impact on cost and schedule. And once we navigated through where the real pinch point was, next slide, it was on this 3-day stripping strength, which is highlighted here, which is one on the slabs. And once we got the performance matrix pulled together, Next slide. We were able to sit down with the concrete suppliers and navigate through what the impact to the project would be. We've got a column here, which is baseline, which is the BC concrete industry average for each of the mix designs. And then option 1, option 2, and option 3 are what we got through from the concrete supplier. Option 1 at 12% is no additional cost to the project. And then option 2 and option 3 are at a premium. But by going through this process that makes the selection fairly transparent, allows the client to make informed decisions about the value and the cost. And we found that this has been pretty useful on projects. Next slide, please. Ayme and I have got lots of experience in this, or lots of examples, so we're happy to share after this. It was just a very quick 5-minute overview of some of the key lessons that we picked up. Thanks, Zahra.
All right, I think I'm next. I'll just share my screen. Right. Okay, so, opening slide, just introduce myself. My name is Phoebe Cullingham. I'm a climate and sustainability manager with EllisDon. Okay, so just to give a little bit of introduction about why EllisDon cares as a construction manager. So we have made commitments through the Science Based Targets Initiative to reduce our carbon emissions as a company. We have a 42% reduction absolute by 2030 required, and then net zero by 2050. And why that particularly matters for us is because we know that material embodied carbon contributes 47% of our annual emissions. So if we want to do anything that we claim we're going to do, if we want to hit our goals, we really do need to reduce our carbon emissions. And we're really thankful for groups like CLF and the City of Vancouver for showing leadership and making it a lot easier for us to, move the industry along this way. And we like participating in events like this because, we're all learning together and we're all moving it forward. So we've gone through this a little bit, what that life cycle stage is for embodied carbon. We know that, we purchase products. That's the major part of the embodied carbon emissions, that first product stage, but also the construction stage is the one that us as a construction manager have the largest impact on. So I'm going to be talking about both of those. This was touched on a little bit by Iain, and we'd see this from the consultants, but one of the biggest things we push towards getting the reductions that we want to get in a building project are performance-based specifications and not prescriptive specifications. So as a construction manager, as a constructor, we need to buy what's in the specs. We are fairly constrained by that. Yes, we can have alternate conversations, we can do RFIs and all that, but it makes it a lot easier if the specifications are very, very clear about what they want from the beginning. For concrete specifically, reductions should be mandated as a volume average reduction from a baseline and not mix by mix, if at all. You can give mix by mix recommendations, but we know that there are actual logistical constraints that happen when we are pouring the concrete on site and things that are very construction specific. We would recommend that plant-specific EPBs be submitted. That really helps validate all the reductions that are being claimed, and it helps support the concrete manufacturers and the plants. They've put the money in to get these EPD calculators, and we want to show them that we actually appreciate that. And then we want to avoid referencing specific technologies. I know there's a lot of companies out there with green tech companies that are saying really great things about how they're going to decarbonize the industry. Some of them are true, some of them are not, and we just want to keep the specifications really technology neutral and more performance based. A really good example of this is the NRC's National Master Specification. Everybody in Canada has access to this, and they've provided a template that does have a performance-based section in it that provides a very good example about how this can be written into specifications. How that trickles down to us procuring that low carbon concrete, this is very similar to what Iain was just going through. This is a version of our bid sheet that we have used on many projects, including in the Vancouver area. So we will break it down element by element and mix by mix. I think this regional baseline is actually set for Ontario, but we would go and update it to the BC numbers as applicable. We have our estimated concrete volumes, and then we're able to go through and compare the reductions offered by a concrete supplier to the baseline. Now, we know that there can be cost and logistic implications towards going to a lower carbon concrete. That doesn't mean there always is, but there can be. So in this process, what we're doing is having them submit their proposed GWP or global warming potential numbers, as well as any of the like strength delay implications. Is it still hitting that standard 28 days or 56 days, or is it longer than that? And if there's a cost premium or elevated cost per meter cube of concrete, then we're able to do a bit of picking and choosing from these unit rates to figure out what the best way to get that lower concrete is on site. Or we can kind of go on those unit rates going forward if we realize we need to tighten a little bit because something was coming over in an unexpected way. Alternatively, we can just get the suppliers to submit the first column, just that single one showing that they've hit that absolute reductions, and we don't really need to move it back and forth. But we know that some clients are really interested in knowing about the cost premium, and they want to reduce their carbon emissions for other corporate reasons or something like that. And they want to know, hey, for how much more money can I reduce the carbon this much? And does it make sense for their project? Because you can buy offsets and stuff, but the best carbon is the one that you don't emit in the first place. The outcome of that previous sheet is this kind of information that's available here. This is data that we pulled a few years ago. It's a bit out of date, but you can see there's no actual numbers associated with it. It's more illustrative. Comparing the offering of 3 suppliers in the Lower Mainland versus their cost and their carbon intensity of their concrete mixes. You can also see that in that lower carbon or low carbon option on 2 of the suppliers, we've identified a cure delay. So as Iain was mentioning, cure delays might be fine for foundations, but they might not be acceptable for slabs when it is a schedule constraint. So it allows us to be smart, basically, about the mixes we're picking and over the course of the building, getting those reductions that we need. Of course, it's not just concrete. There is other materials to consider. The largest ones being structural in terms of the embodied carbon density. So for metals, that's something we're working through a lot right now. We've seen some huge improvement in the industry over the last 12 months, honestly. And we're seeing metal mills, brokers, and fabricators advancing their understanding of embodied carbon and the accessibility of the data. Largely, the data comes from the mills themselves, and then there's just a percentage increase applied for the fabricators, but mills vary widely depending on the location that they have their plants, their energy source, what kind of basically furnace they're using, or metal production system, and then also the percentage of recycled scrap in their metal. So starting to ask for that information is really important. Other materials should be considered more in the design phase. It is very much supplier to supplier dependent here, and there's not enough good quality data at this point in time to write procurement stuff into the specs. You might be reducing yourself to one supplier at times. Though as the industry advances, this will change. We're just not at a point right now where writing in carbon reductions for largely envelope materials is very effective in the industry, particularly as the previous presenter said, the Canadian landscape for plastics-based insulation has changed a lot since 2021, and a lot of the blowing agents that were previously very, very carbon intensive are no longer being used. So there's a lot more parity between the suppliers now. But in materials where you can get that reduction, where the data is there, specifications should include a reference to a percentage better than an established industry average. It's always helpful if that industry average is actually written into the specification as well. Or you can put an absolute value as well. The more demand there is for documentation in the specifications, the more documentation will be readily available. We know that the market will respond to it, but we need to make sure that we're asking for this stuff at a very consistent and repeatable way so that our trades know what kind of documentation that they need to supply. And then, yeah, product-specific data is required to demonstrate reduction from a baseline. Something we see frequently, especially in metals, is we'll ask for an EPD and we'll get the Canadian or American average EPD coming back to us, which is great if you're doing a compliance things for LEED, but it can't, a baseline, an average baseline can't show a reduction from an average baseline. So you do need that product specific data. Finally, as I mentioned, I will talk about the transportation and installation materials. Construction stage data is very weak in the industry. It relies on estimated factors. Those factors vary from software to software, and there's very little consistency and very little understanding. So the City of Vancouver wishes to better understand the real world impacts of construction processes and is incentivizing that developers and constructors track and disclose this data. And I know that Zahra will talk about it a bit later, but when combined with other initiatives, up to a 5% leadership credit is available, and some of that is for tracking that A4 and A5 emission. Currently, EllisDon is running pilot projects around the country, including many in the Vancouver area, for tracking those on-site emissions. Deliveries to site are A4, and fuel and power used on site are A5. And in order for us to get this data, what we do is we tie it to the monthly billing. It's part of our baseline contracts, though we only kind of activate that on specific projects with the goal to eventually have it active on all projects across the country. But we do tie it to the monthly billing because everybody wants to get paid, and it's a lot easier to, get that data submitted when there's a little bit of a stick. But also some of that data can be streamlined with logistics software, particularly delivery scheduling software. So in the Vancouver area, when there's going to be a lot of zero lot line projects or just issues with backing up on the streets, some of you might be using logistics software already. Examples are Voyage Control and StruxHub, and we are working with those companies to make sure that they have a way to track the carbon emissions associated with the deliveries. We're not the first company to do it. They do have experience doing this, but working with them to streamline as much data collection and put as minimal lift on the level of effort needed from project teams as possible. And just a little bit of a show about what that tracking looks like. We have kind of template data set up so that we can see the output of this tracking. How does it change from project stage to project stage? And what this does is that it really can help project teams identify carbon hotspots, right? And then put money or effort into the most impactful ways of reducing this carbon. It also can help initiate policies to reduce any carbon wastage. Examples of this would be anti-idling, battery power, faster grid connections, formwork heating, kind of all of those things. Things that are part of the construction process, but we might not be thinking about it because they're just, we have to do this to keep moving. If we're able to take a step back, see, wow, there's a big impact from this decision that I didn't really consider, we might make different decisions in the future. So, and I guess just to clarify what we asked the subtrades to report in terms of fuel, and we track ourselves, is any fuel consumption on site. So like liters of whatever kind of fuel, be it diesel, propane, that kind of stuff, as well as our energy purchases or usage. So if we have the data to collect electrical grid connections or any fuel we buy to operate any of the equipment on site. And we are looking into alternative power solutions like hybrid generators or solar on site, that kind of stuff. We have kind of early stage pilots around the country working on that. And yeah, that's my presentation. Thanks.
Thank you, Phoebe. That was great. Our next presenter is Shane. It's fascinating to just hear presentations from different perspectives. So far, we have heard from a sustainability and consultant. We have heard from architect perspective and general contractor. So Shane will share with us a little bit about concrete suppliers' perspective.
Great. And are you seeing my full presentation at the moment?
Yes.
Okay, perfect. All right, so yeah, my name is Shane Mulligan, and I'll turn my camera on here too, if I can figure out how to do that. There we go. My name is Shane Mulligan. I'm the Sustainability and Technical Marketing Manager at Heidelberg Materials. I'm going to highlight some themes that are pretty similar to what we've seen here already and what Matt Dalkie at Lafarge is going to be going into as well, but dive into some kind of real world numbers to kind of illustrate the impact that the Vancouver Building Bylaw is likely to have on concrete and vice versa. So, as a general rule of thumb, concrete typically contribute somewhere around half of the overall embodied emissions of a given project. It might be a little bit more, might be a little bit less, but overall, as a singular material, we have a pretty significant impact on the overall reduction efforts that a singular material can have, generally in a relatively cost-effective way versus other alternatives. But it's important to kind of get a sense of how these reductions are both achieved and measured. And so the benchmark that the Vancouver Building Bylaw is using for concrete to demonstrate reductions against is the document highlighted here on the screen, which is the Regional Industry Average Environmental Product Declaration for ready-mix concrete. There's a lot of background into what exactly that entails, but essentially it is a report that outlines the environmental performance and carbon intensity of typical concrete mixes throughout British Columbia. So it includes both a recommended benchmark, which is highlighted in blue in this chart, as well as several alternatives concrete producers can point to as being indicative of their performance based on slight variations to the overall mix design. So highlighted on the screen here is an example of a 35 MPa concrete application with no air entrainment, be similar to what you'd see for an interior floor slab as an example. And the base mix for this concrete includes ordinary Portland cement, type GU cement, and 20% supplementary cementing materials, which would be either fly ash or slag, most generally in the Vancouver market. And as a result, the carbon intensity of this particular mix is 293.75 kilograms of CO2 per cubic meter. And that would be the value that ultimately informs a whole building life cycle assessment's baseline calculations alongside all the other concretes and building elements that make up that project. So to demonstrate reductions against this concrete mix, concrete producers in Vancouver could go further to the right on this chart and show a 10% improvement on carbon intensity by testing that their mix is going to utilize Portland limestone cement, type GUL cement, and slightly more SCMs at 25% substitution. So in British Columbia today, if a concrete producer is using local cement, Portland limestone cement is now the standard. So the cost implications of this move are essentially cost neutral. And similarly, with a 5% increase in total SCM use, you're going to see a 0 to very marginal cost increase, depending on the producer and their own supply chain considerations. Essentially, though, 10% carbon reduction with concrete is possible at a very low cost, which generally means about a 5% reduction on the entire building. And a concrete producer can go a little bit further on this chart and attest that they're going to be using Portland limestone cement and 40% SCMs, which would demonstrate about a 20% reduction of concrete, which is possible. But as you get into these higher levels of SCM use, you're likely to start encountering some trade-offs. And at these higher levels, one of those trade-offs is likely to be schedule delays. So this 40% SCM mix is probably more indicative of a 56-day mix versus the traditional 28-day mix, which could result in some stripping delays, which your project may or may not ultimately be able to accommodate. And so depending on the concrete producer and their supply chains, that higher use of SCMs might also come at a higher cost. And so while it is possible for concrete producers in Vancouver to demonstrate this 20% reduction, it definitely requires some strategizing between the design team, the general contractor, and the concrete producer to manage the associated trade-offs that would be associated with that concrete. Taking a bit of a step back, looking at where the industry is relative to the rest of Canada, we've come a long way in recent years. British Columbia has demonstrated a very significant reduction in average carbon intensity of concrete when compared to the Canadian-wide industry average report that was generated back in 2017. In fact, British Columbia is among the lowest carbon concrete in Canada as it stands, which is largely due from the use of local cement production and some of the geographic advantages that exist from a climate perspective and some of the transportation of raw materials, such as the water-based transportation of aggregates, for example, at a lot of our concrete facilities. And so, picking up from our industry action plan that Matt Dalkie, I think, is going to delve into a little more detail on, the cement plants in the Lower Mainland are already producing Portland limestone cement as a standard and utilizing lower carbon alternative fuels to reduce combustion emissions. And this has resulted in relatively low carbon cement versus the rest of Canada, but also indicates that much of that low-hanging fruit that exists for the cement industry elsewhere in the country has already kind of been taken advantage of in the Lower Mainland. So on the screen, we can see how the BC regional average concretes highlight from that last slide are compared against the past. But some concrete producers are also able to generate what we call product-specific EPDs. And so these concrete producers have invested in the ability to generate these EPDs that are specific to the mixes that they generate, they're able to produce. And this may demonstrate natural improvements against the industry average benchmark in general. So at Heidelberg Materials, all of our plants are able to produce product-specific EPDs, and it supports our branded low-carbon concrete offering, which is known as EvoBuild. Similarly, Lafarge has their EcoPact product. There are a number of producers on Vancouver Island that have invested in this ability to do product-specific EPDs as well. And it really just speaks to the industry's readiness to take on some of these policies that are coming out that are focused on embodied carbon and demonstrating with transparency our ability to perform here. Each supplier is definitely going to have their own capabilities and supply chain considerations. But again, if we work directly with designers and contractors to achieve the targeted level of carbon reductions, we can manage the schedule and cost implications to best suit a given project. And then in the not too distant future, cement and concrete will soon be able to deliver even more substantial carbon reductions across Western Canada. A number of carbon capture, utilization, and storage projects are currently under development across North America, including Heidelberg Materials' Edmonton, Alberta facility, which is currently targeting completion by 2026. So this is a first of its kind project that's going to see the capture of 1 megaton of carbon emissions annually from the cement production process, ultimately enabling net zero cement production by 2027. And while this product is much more likely to have a substantial cost impact at a product level versus some of the other alternatives we're highlighting here today, it still has the potential to reduce the carbon emissions of a project by up to 50% at a relatively minimal project level cost. And I understand that this isn't necessarily a pathway that everybody's going to choose to go down with their given project, but it does demonstrate the cement and concrete industry's readiness to provide solutions to support performance against embodied carbon regulations that are coming out both now and into the future as they continue to grow more stringent with time. So with that, happy to turn it over to the next presenter, and thank you very much.
Our next presenter is Matt Dalkie. So I think he should be on now. I'll just let him share his screen.
Hi, everyone. Just bear with me a second. I'm just putting up the pull up the presentation. Okay, so thanks for the opportunity to speak. As Shane pointed out, the industry has a Concrete Zero roadmap. So it was put together by the Cement Association of Canada, but covers both cement and concrete and concrete products. This is what the overall target looks like as far as where the industry sees ourselves going, and these are on a total CO2 emission basis, not based on intensity or anything like that. So achieving net zero by 2050 is what the target is. That reduction is broken down into a number of different areas of specific interest to the for the Vancouver area, and the bylaws will be the cement construction efficiencies and also concrete improvements. So the 3.7% and the 2.1% in the purple. Those are the ones that have the most impact as far as, or the most influence as far as the policy that Vancouver is putting in place. As far as recommendations for policies, from a Lafarge perspective, we recommend that any policies are material agnostic and should be treating all structural materials equitably, and to focus on performance outcomes. And in this case, we really want to focus on functional equivalence of different building systems. We recommend that policies strive to recognize improve structural resiliency, and by this we mean that if you are building a building out of a combustible material, for example, or something that is not as durable as a material like concrete, that is recognized. So if there is a wildfire or flooding or earthquake, different structural systems will react differently to those sorts of events. And when you're looking at concrete, that tends to be much more resilient, and we're able to return the structure to use earlier after a significant event. We also want to promote local versus imported materials and recognize that as well. Now, Shane did point out that Lafarge does have our EcoPact range of concrete. So we start on a basis of OPC cement, so straight OPC cement as a comparison. And we start by a 30% reduction versus OPC cement, and that brings our EcoPact product. When we achieve a 50% reduction, that's our EcoPact Prime product, and then 70% and above is our EcoPact Max product. So that's the different ranges that we have for our EcoPact product, and similar to what Shane was showing before, as far as the numbers that you see in EPDs as well. Just to look at those in a little bit more detail. So the reductions are achieved through the use of GUL cement, which Shane was talking about. We leverage our experience over several decades of concrete production and optimize the use of the types of aggregates that we are using and how they are blended together. Our production in the Lower Mainland predominantly uses NewCem SCM, which is a slag-based SCM, as a way of reducing the cement content in the concrete. And we also leverage our experience and partnership with admixture suppliers to optimize the use of admixtures to further reduce the amount of cement in concrete. As far as costs go, generally speaking, for our non-EcoPact concrete, they tend to have somewhere in the order of 5 to 10% embodied carbon reduction in comparison to the industry-wide EPDs. But when you're starting to look at higher reductions above that and starting to use EcoPact concrete, the costs can vary depending on what strength class it is that you're looking at. But we recommend from a budgeting perspective to allow for a 5% increase in cost, and that should more than cover you as far as you know, the potential elevated costs for using an EcoPact concrete. As Shane pointed out, we can go to those much higher levels of SCM and therefore much lower embodied carbon, CO2. But bear in mind that there may be additional curing and there may be schedule impact implications for using those higher levels of SCM. Although there may be schedule impacts, there are technologies available such as in situ strength monitoring, and that can be leveraged to actually offset some of those potential schedule impacts. As far as the future availability of EcoPact and similar low carbon concrete offerings, many people will be aware that SCMs are becoming an increasing issue as far as their availability in the marketplace. As I said, Lafarge uses slag as our primary SCM that we use in the Lower Mainland, and we are always exploring other SCMs and bringing those onto the market to allow ongoing production of low carbon concrete through the use of SCMs. And that's it from me. So I'll hand it over to the next presenter.
Our next presenter is Tom Place from Equilibrium. So Tom, go ahead.
Thanks, Zahra. Yeah, so thanks to everyone that's presented until this point. So the purpose of this presentation, I'm Tom Place. I work for Equilibrium, who are a consulting structural engineer here in Vancouver. And I want to just give a little flavor about the structural engineering approaches to reducing embodied carbon and the strategies we take. So just as a little bit of context, there's going to be some parallels between what people have spoken about before, but generally speaking, for buildings, particularly for Part 3 buildings, we're going to be looking at embodied carbon of the structure being at least half of the total embodied carbon on the project. And it varies a little bit depending on the scale of the building, but that's a big part of why structure is seen as critical. Reducing the carbon in the structure is seen as critical to hitting those targets. And building on the information Zahra was talking about earlier, so the proposed clauses that are part of the 2025 Vancouver Building Bylaw give two routes for projects to demonstrate embodied carbon compliance. So the first is a baseline comparison where you take kind of a functionally equivalent building, demonstrate through design changes that you've saved carbon, and then demonstrate the reduction that route. The other alternative is the absolute benchmark of just quoting the overall embodied carbon per square meter. And I think the main message from me would be that a lot of our focus from a sustainability point of view is towards 2030 and beyond, and that's where lots of this research and development is coming from to try and achieve. But the initial targets that are being proposed for Vancouver for the 2025 code should be seen as quite simple targets to achieve. They're a stepping stone into something that is going to be much bigger. So for now, 2025 shouldn't really be of a great concern for people on this call. The main message from a structural engineering perspective is kind of on this slide, which is to say, as structural engineers, we spend less time focusing on specifying sustainable materials and rather in designing out embodied carbon by using less stuff. So that you'll see quite commonly images like the one on the left there that talks about a hierarchy of building less and building smart in structural engineering in order to reduce the amount of material we have in the project in the first place. And often the advantage of that is reducing material can quite often save money as well as save carbon. So there is a design incentive there for us to use materials efficiently. And how we do that takes a number of ways, but refining the structure can mean reducing the spans that we have. Has a direct impact, quite a big direct impact on the amount of material in a building. Removing transfers is talked about a lot, and that requires kind of the buy-in of the whole design team and client. Changing the floor framing is a slightly more subtle art of playing either using point-supported structure or playing with the beam framing layout to save material. And then certainly another big impact is to reduce basement volumes. And the City of Vancouver have been changing policy to try and help with parking minimums and reducing basement volumes. Some other messages I would give is, as a design team, to challenge the brief. In Vancouver, which is seismically governed, then reducing the floor loading will help both to reduce the thickness of floor structure, but also the weight of the building designed for a seismic event. And it's worthwhile challenging your structural engineer and having that conversation early, if you can, to reduce the design floor loadings required, provided they still comply with code and the client's requirements. Reducing parking I mentioned, and then a big part of the conversation for post 2030 is how we utilize reusing what's already there. So strengthening, upgrading buildings, reusing reclaimed materials, timber and steel in particular lend themselves to that, but there's also opportunity for reusing aggregate. And then to put some numbers to it, so from a structural efficiency point of view, there is some information out there. There's a good study that was produced by Bureau Happold looking at a mid-rise concrete structure based on a flat slab 9x9 grids that looked at the impact of, well, firstly on the left, reducing the column grid. So they found that for every reduction of 1.5 meters in their column grid, they were saving about 20% in the overall embodied carbon of the structure. So your structural engineers should certainly be looking at column grid very early in the project if embodied carbon is an incentive, which it should be. Reducing column grid, really refining that in post loading, again, slightly smaller advantages by refining your loading, but a project that is able to shave down the loading could potentially be saving 10% on the materials through that. And then the kind of third big thing is the framing layout we choose to use as structural engineers. So in the Bureau Happold study, that they found that going from a concrete flat slab to a beam and slab structure, it represents a more efficient use of materials, a smarter use of structural depth, and alternatively going to post-tension slabs rather than just flat slabs is also a pretty good strategy if you're looking to keep a building height, you're restricted by a building height, or you're trying to keep the same building height. So main message being, it's not just about materials. The structural engineer can help you a lot if you're trying to drill down that embodied carbon. Have those conversations early, and really use the form of the building to help you achieve targets or to demonstrate reduction. The second has been talked about quite a lot today, so I'll try and keep it fairly brief, but specification should come second, but is no less important. So with concrete, as Shane and Matt have mentioned, there are savings to be had, and in Vancouver now, the Lafarge and the Heidelberg plants, cement plants, both producing only GUL, so make sure that that is being accounted for in your calculations when you're reporting carbon. A big thing we found that helps developers is to set a total carbon budget on our project and then work with the developer and the suppliers to decide where to put any SCMs that are on your project, rather than dictating as designers to the contractors where they are and having negative effects on a program. Steel, so the local steel supply comes from across the border in Seattle, and that plant is an electric arc furnace plant. So be aware that electric arc furnace steel typically has a lower carbon impact. So again, take advantage of that when you're doing your calculations. And then finally, when it comes to timber, Vancouver and the Pacific Northwest are really a global leader in mass timber. We have not only the materials here, but also the skills to be able to design with mass timber and erect. And the upcoming BC for 2024 is going to permit up to 18 stories of encapsulated mass timber. So there's quite a lot of innovation ongoing in all materials that can help you achieve and actually exceeds some of those targets that are being discussed. Quickly again on the left to mirror what Matt and Shane have talked about. So for even a 15% SCM mix, you're looking about a 20% saving versus a standard GU no SCM mix, and there are some quite big savings to be had if you want to do them. I also would just highlight, in terms of materials, that's a study we completed for a project just across the border in the US, and there we were looking at kind of the comparative baseline study, and we're able to demonstrate a 30% saving by going from, in that case, it was a full steel concrete structure down to a hybrid steel and mass timber structure. So there are lots of different routes, however, whatever works for your particular project, but there are lots of different routes to demonstrate savings and to save carbon beyond just specifying a particular material. And then finally, I wanted to just give some kind of signposting towards the long-term view when it comes to structural engineering and where the industry will be in 5 or 10 years' time. So again, on concrete.
Hey, Tom, sorry to jump in. We're kind of running a bit short, so if you could try to just on the agenda, so if you can try to wrap up quickly, because we don't. Yeah, thanks.
Final slide. So the Global Cement and Concrete Association have produced this roadmap for getting to net zero by 2050. So that's what the graph on the left is showing. And the main point I want to make on that is the top green bar, which has nothing really to do with concrete. It's all about kind of design. So they're assuming there is a 22% saving by 2050 just purely based on efficient design. And there's no reason you can't be designing efficiently now to get a lot of that 22%. Second point is we have a lot of building stock in Vancouver that maybe we are deeming is not quite suitable now, but there are opportunities to upgrade and reuse some of that structure. So there are some good examples globally about building reuse. One shown there is Triton Square in London, where they refurbished the building, refurbished all of the facade panels, used carbon fiber strengthening to strengthen the building and actually extend it vertically, and then finally design efficiency. So there are lots of routes even now for us to change the structure to make a pretty significant saving, say up to 50% in embodied carbon, purely based on the form and material. And also there are changes going on to look at reducing basements, reducing transfers, all things you can do now, but will need to continue to be done moving into the future. Thank you.
All righty, everybody can hear me? Well, thumbs up, maybe.
We can.
Yes, we
Can
can
you
hear
see
you.
my screen here? All right. I've been told to keep this brief, so I will move along pretty quickly, but I'm always available for questions after any time. I'm sure Zahra will send out contact info, but I am Nathan Shuttleworth. I'm the Director of Development for Third Space Properties. We are a local property management and real estate development firm. And I want to share a few lessons learned that we've had, and quite frankly, a few unanticipated successes we had with our first project that's currently under construction. A little about Third Space. We are committed to a triple bottom line development company, and that means that we had committed to net zero by 2050. And so in advance of any municipal policy, we're already running 3 to 4 LCAs on every project. Initially, really just trying to understand where we're at. As this slide will show, and pre-opt had calculated, Anthony can speak to the details a lot better than me, but our baseline, which means just where the building sat before any measures to try to mitigate embodied carbon, was about 350 kilograms CO2 per meter squared. This isn't to be confused with kind of the baseline as calculated by the policy that Zahra and her team are proposing, but that's kind of where we started, just without any measures at all. And we're moving ahead here. All right. So the first thing, as everybody's mentioned, structure, concrete. It's the biggest thing. It's the biggest thing to address. Luckily, we had a great partner right off the bat with Glotman Simpson. I saw Harrison on the call earlier. So they came to us right out of the gates, just in terms of initial design, and 3 real options right away to try to reduce our embodied carbon, and really ultimately just reduce concrete in the building. So we looked at foundations, the parquet suspended slabs, and the L2 transfer slab, which is highlighted in the image on the right. The first one, and and as Harrison can speak to again, perhaps not an ongoing strategy given the updated seismic codes, but we looked at reductions here again, partly through mix, but partly just design. This is a trade-off between essentially rebar and concrete volumes, but again, just trying to drive down the use of the concrete. We also looked at the parquet suspended slab, and this is really moving to column capitals. So what you're trading off here is a 10-inch flat slab. This is what you'd traditionally see throughout parkades in the Lower Mainland. It's super easy to form and it's easy to coordinate services. Whereas on the right, you have 6x6 column capitals, and you can reduce that 10-inch slab down to about an 8-inch slab. And then some different mix as well in there. And then the transfer slab, I think Tom mentioned this as well in terms of strategies. We did look at this in terms of trying to go to a beam system instead of just a flat slab. We were limited in height, both in our zoning and then also in our requirements from the future tenant. So we didn't go to this option in the end, but we did have them costed out. So our build partner Axiom had a look at these initially. Just to see kind of where we were early days ballpark and what these strategies, and a pleasant surprise was, there's a bit of a savings here. This isn't a huge number on the whole, but it's enough to say that, we can go ahead with this and we're not really risking massive premiums, right? And as I said, we didn't really go to option 3, but through simple manipulations of just the structure, Harrison working with the architectural team, we take that 18-inch typical transfer slab down to a 16-inch slab, and there's some reductions in there as well. So overall, without honestly a ton of work on our end and any cost, potential savings, we had about a 9% reduction from concrete and rebar with building. Again, not huge numbers, but honestly things that are super easy to do and easy to implement across our projects moving forward. And the second one, this actually goes back to Chad's presentation and whole life carbon, and combining both the operational emissions and the embodied, and a lot of good discussions in the chat here. But as you can kind of see, our baseline wall, we had 2 inches of exterior insulation, not a lot. But as we've already committed to an all-electric building with really, quite frankly, highly dominant mechanical system, we've also committed to putting cooling in all of our buildings. So that often leads you to heat pumps or similar, which are kind of mechanically dominated systems in terms of the energy efficiency design. You can see we're exceeding the COV requirements by quite a bit. So we did look into various strategies to see, what the trade-offs were if we took some insulation out of the building. And as you can see here, we could have an immediate reduction of about 30,000 kilograms, or we could have about 76 kilograms per year reduction. And in simple math, this is very simple math, as people would caveat, that's almost 400 years to take that savings back. So on the surface, a very easy decision, not really one, as people have mentioned. We looked at this from a number of different lenses before making a decision. The first one is thermal comfort. Does that 2 inches of insulation coming off the exterior, off the roof, make a big difference? Very minimally, honestly. The windows are the weak point right now. So that is still the main kind of issue, especially with your exterior walls being primarily window at this point, in terms of that, where people are going to sit and going to feel that different temperature difference. We also looked at whether that's affected equipment sizing, and it didn't. We ran the building in a 2050 energy model in terms of the climate file. Lots of debate about whether that's hot enough. It's probably not. But again, the mechanical system could still keep up. We ran it in a power outage scenario. Very marginal difference between 2 inches of exterior insulation and not having it. And then we even had our acoustic consultant have a look at it and comment of whether or not that would make a big difference. And again, it's really windows and not so much the design of the windows themselves, but also just the air tightness, that speaks to that as well. Now, the big thing, and we've had this conversation with Chad, who's obviously on the call, is durability and how much we're sacrificing for this initial capital cost savings over time. We know that the exterior insulation will protect the membrane and hopefully improve that air tightness over time. Unfortunately, we just don't have a lot of data either way to kind of stand behind when we're looking at these decisions. And certainly we're looking at trying to minimize our costs. There's currently kind of on a runaway train right now in terms of the upfront capital costs of construction. So we did, in this case, elect to take that savings, but not without a whole lot of kind of consternation and studying. And I wouldn't say this is just a no-brainer going forward. You really need to look at this in depth and see whether or not it makes sense for your project. But I think there is a lot of synergies between embodied carbons and trying to reduce your capital costs. It is ultimately just about trying to use as little as possible, and that should translate into capital cost savings. So overall, again, you know, the insulation being the biggest one, the hardest one to quantify, but overall we were easily able to get about a 9% reduction in our carbon. And again, that's from our own baseline of 350. So, you know, we're looking at pretty much a 20% reduction from that 400 kilogram CO2 per meter squared baseline. And at worst, it didn't cost us anything. And at best, we actually saved a little bit of money along the way. That is the end of my presentation.
Thank you, Nathan. So I'm going to take it back on again to, and now after all these presentations, share with you what we're proposing for the Vancouver Building Bylaw. I'm sorry if it felt like a little bit of a jam of information. I've had conversation with every one of these presenters, and every one of them provided so much valuable insight that I thought it would not do justice if we just go ahead with sharing what we're proposing and not the background and based on what we're putting it. So just to not take more time, I'm just going to share my screen. So you have my presenters view now, right? Okay.
Yeah.
So I'm going to have to run maybe a bit faster than initially planned, just to give enough time for us to have a discussion. So in terms of what we started with in our proposed approach, because of what we've heard prior as we put out the 2022 proposal and all the way through, we identified a few key solutions that we found that can just by themselves result in